Until now, we have learned how to set up the DynamoDB on my local using Docker Compose. So in this, let's try setting up a small little code snippet that would where we would use Node.js to connect to the Docker container that is running our code. That is running our uh, DynamoDB. So we'll create some table and create records operation in that table. So let's start with it. So let's set up, initialize our node project. Let's do npm init. So yeah, it's fine with me. All good. So let me do index.js for now, which I don't have, but fine. Keywords, author, fine. Everything is fine. The next step is I need to install npmi, couple of packages for AWS to connect to DynamoDB. So one of the packages AWS SDK client DynamoDB, and the other one that we would need is library of DynamoDB. So let me pick this up, and here we go. So now let's create a file that would help us to connect to our DynamoDB client. So let's name it as dynamo client.js. So first thing we need to do is import DynamoDB client from client DynamoDB. So what we want is to export a constant client that is basically new DB client. What the configuration that I would need to provide is the region. I would keep it US East 1 for me, and the endpoint, since we would be connecting it to our Docker container. So let's do it HTTP colon localhost 8000. So let's now create a new file where we want to create a new table. So create table.js. So here we want to import the client from the command, that is create table command from client DynamoDB. So let's, before we proceed into defining our table description, let's decide what we want to create. So since the table is going to be for a to-do list application, so the purpose, so we can keep the name as to-do. Now the attributes that we would need is, one would be the user ID that would help me as to identify. I would call this as PK, and the other could be the to-do ID that would serve as the sort key for me by default. The next item would be, because it's a to-do application, so we can have a due date. So this would, I did not mention its type. So this both would be of string type. This is also string. And next would be the priority, as in P1, P2, or so we can have it as string. And the other and the final part that is very important for any to-do application is its status of any to-do. So I'll keep this as second string. We can keep it as Boolean also, but I'm keeping it as string just in case I want to mark the status as to do in progress or complete or any kind of statuses. So this could serve as a versatile database structure for me. So since I have defined the attributes, so let's go with the key schema now. So for the key schema, I'll keep the user ID and primary key. So since I am going to call the user ID as PK and your to-do ID as SK, as in sort key, PK would be my hash. Now, sort key, since we already have decided it, so we can keep it as range. It will be range. So now let's define our local secondary indexes and global secondary indexes, what we want to keep. So this is a vital piece when you're structuring your table or defining the attributes, because you want to structure or define the table as per how you would be reading the table data. So one is by default that I would be listing all the to-dos of a particular user. So the other is I would maybe by status or by due date, I would fetch it. So since I would need to group it, the to-dos by the user ID. So I'll need the user ID as the hash itself. So I'll need to define it as local secondary indexes. So one would be your PK is hash and your due date. So let me call this as by due date, and my sort key in this case would be due date, and its type would be range. We can have it for status in case you want to filter it by status. So this should help us. So PK is again my hash here. My sort key in this case would become the status. This would serve as range. Third, by priority. So here the PK is hash and my sort key becomes the priority key. Again, I will take some time to get used to it while speaking and typing at the same time. So we have defined this. So I'll just populate this quickly in the code. So for code, let's define a function as create to table as new create. Okay, this would be a function for me, and instant table definition, new create table command takes in the attributes as the table name. So we would have it as to do as we discussed. Now let's keep the billing mode as paper use, paper request. So now the attribute definitions we had name as primary key. So this is my basically the user ID. I'm writing here for our reference later on. And the attribute type is hash. So just one piece of information. So when we are using this client DynamoDB, and especially the AWS SDK, it doesn't give us many options like you would have seen here. It just gives me a Boolean, number, and string. So I don't have whole lot of options here. As usually, like I do have complex data structures available in Dynamo, like list maps. This is not available through SDK, but I can write it. So which we'll see later on. So let's complete this. Let me just copy paste and update the keys quickly. So here it's to do ID. Just keeping it as the name. So this would be my status. This can be my date. Everything is a string right now. Okay, just fixing the typos. Due date priority. Okay, so how many 1, 2, 5. So we have 5 attributes listed. Now let's go and define local secondary indexes. We have the key schema as well. So for key schema, again, it would be, this would be key type. This here hash. And this is again key type. Let's fix it. This is going to be range. This is SK. Basically, your user ID, we have already mentioned it. Let's remove it. Okay, we have defined the key schema. Let's now move to our local secondary indexes. So we had 3. I'll just refer it back. One was by due date, by status, and by priority. The first one is by due date. Now we could define the key schema. So here the key schema is the primary key remains the same. Just need to hash. Let me actually copy this instead. Okay, this is going to be range. This is due date. Let's copy the structure to do this. So next is by priority. Ty priority. This is by status. Okay, this is wait client. Since we have the client exported DynamoDB client dot send needs to be the table definition. Okay, and table was. So we can pick table description dot table name. We can have it. So let's do log table created. Table. Okay, since we are using this as a weight, we need to keep this in async. Let's wrap this in try catch block just as for the good implementation. Try catch error. Okay, if there is any error, let's just log it with specifying error creating table and mention the log the error. Okay, create to do table. So this needs to specify, since this is from our local and I'm using JavaScript. If see we have node modules done, create table. Let's try and run create table. Before doing that, let's test what all tables we have. DynamoDB in our DynamoDB. DynamoDB, the command for that is list tables. We need to specify the endpoint and this URL. So it is http colon post. So it is just cars. Let's try and run our create table file. Okay, this is still validation. Must have a projection specified. So I missed specifying the projection for the indexes. So let's fix this. So the projection is basically what all you want to save. So the projection key, the projection type, and I want to save all the respective data around it. So I'll keep this and copy this for all the indexes because I want it the same for all. The comma here. Let's this time it should work. Here, node. So it says table created with name to do. This is the log that we published here. So just to verify, we can run our DynamoDB. So this was the listables. So if you see, we have to do now, which we only had cars table.